Right. Next up, we are going to take a look at simplifying irrational numbers. So again, we'll start with our curricular outcomes. We'll look at mixed and entire radicals, and then formally talk about how we simplify them. So curricular outcomes. We want to represent, identify, and simplify irrational numbers and put them in order. We also want to use technology to investigate and solve problems of organization and manipulation of information, and manipulate data using charts and graphs in order to test inferences and probabilities. Now, a review. In an entire radical, all factors and variables are within the radical. So, the square root of 48x to the fifth is an entire radical because there's nothing in front of this sign. Everything is under that radical sign. In a mixed radical, some of the factors or variables are outside the radical. So taking this same 48x to the fifth, 48 is the same as 16 times 3. Square root of 16 is 4. We could pull that out. We could pull out a couple of our x's. Now we have a mixed radical. Just as a mixed number has a whole in front of a fraction, a mixed radical has numbers that are not part of the radical and other numbers that still are within. We want to take a note that the square root of 48x to the fifth is 4x squared root 3x. These are the same number written in two different ways. So, simplifying them. Radicals are considered simplified when they are written in mixed radical form. That means nothing under the radical may be removed. So the square root of 48x to the fifth is not simplified at all. Right. This one, where we pull out a factor of 4, that's partially simplified. It's partially simplified because we still have perfect square factors inside. We pull them all out. Right? Now we pulled out all of our 4s. This is still only partially simplified because x has perfect square factors within it. X to the fifth, 5 is greater than 4. 4 is an even number, so x to the 4 can come out and become x squared. So fully simplifying is when we pull that x squared out. Let's take a look at more examples. We want to fully simplify 180x cubed, or the square root of 180x cubed. Let's take a look at our factorization. We've got factors of 2, 3, 5, and x inside. Pulling the x cubed apart, because 3 is odd, we leave one x behind, pull the rest out so it has an even exponent. Now everything with even exponents, those exponents get divided by 2 and brought out to the outside, leaving us with a 5x under the radical. So the square root of 180x cubed is the same as 6x root 5. Here we're going the other way. We're writing it as an entire radical. That means that 14r has to go into the radical. We do the process in reverse. To put them under that radical, under the square root, we have to square them. So 14 squared times r squared times 11. That's 196 times 11 r squared s. R and s are two different letters. That makes them two different variables. So they cannot be combined. We don't have an r cubed or an s cubed here. It is r squared s. Now 11 times 196 is 2,156. So the square root of 2,156 r squared s is our entire radical. Example 3, find the area of a rectangle with a length of the square root of 6x units and a width of square root of 50x cubed units. Write it in fully simplified form. Well, area of a rectangle is length times width. So we're going to multiply these two together. 6 times 50 is 300. X times x cubed is x to the fourth. Now we could pull our perfect square factors out to write it in a simplified form. Here we have the correct entire radical. We need the mixed radical. So that factor of 100 is a perfect square, comes out to become 10. X to the fourth comes out to become x squared. We're left with only a root 3 inside. Exercises. Time for you to try some yourself. Fully simplify the square root of 98t to the 7. Pause now if you need more time. All right, 98 is 2 times 49. That 49 is a perfect square. And 6 of our t's can come out to become 3 t's. Now, we're going to write this as an entire radical. 15q cubed times the square root of 7q. Pause now. Take all the time you need. Okay, writing it as an entire radical tends to be a little bit faster than a mixed radical. We're putting everything in, we square it. So 15 squared times 7 is 1,575. Q squared is q to the 6 times the q we already had makes q to the 7. Now here, a rectangle has an area of 75x squared and a width of root 15x. What is its length? Pause now, take the time you need. Remembering that area is length times width. Given the area and the width, the length would be the area divided by the width. So 75x squared divided by root 15x. If we square the 75 and then divide it by 15, we get 375. Square the x squared to put it under a radical, divide by x, we get x cubed. So this simplifies to 5x times the square root of 15x. All right, in summary, unless otherwise specified, always write your final answers as fully simplified mixed radicals. That's part of the simplification process, just like we expect you to write 1/2 and not 3/6 when you're dealing with fractions. Reversing that simplification makes entire radicals. Probably an easier process because you don't have to do any factoring. It's just multiplication. So if you have any questions, any feedback for me, please leave them in the comments and I will do my best to respond in a timely manner.